Let's talk about what's the deal with Python. How come Python became all of a sudden, language to go? There's a little bit history behind this. There are certain reasons why Python is good, and first of all, it's very general purpose and high level and interpreted programming language. So that means in the Python shell, when you write code, the code, when you look at the code itself, later on this will become, of course, more obvious. Code itself is relatively simple. It has certain intricacies, but it's much shorter and cleaner than the code that you write in C# or Java. Okay? And the emphasis in Python is on readability. And there is a library, standard library that comes with Python, which is readily available, and you can clearly use it. Just like Java, there are a lot of libraries that are available to you. And you can also, Python is also supports other programming paradigms such as object-oriented, imperative, or functional programming paradigms are also supported in Python. And finally, it features what we call a fluid dynamic type system and automatic memory management. Both of these are important, and there are main differences of Python, and I'm going to explain this with some examples later. But for now, let me tell you this. In Python, when you create variables, you don't declare them. So when you assign a variable on the left side of any equation, that variable at that point is created, and whatever is on the right side, it may be integer, it may be float, it will take its type. So dynamically, the type of the variable will change when you assign variables. So it means, unlike Java, where you declare a variable to be, let's say, an integer, at that point on, you can only assign integer variable values to that variable. Python actually has this dynamic system where the types actually changes. Now, this system has, of course, its benefits, but of course, there are also downsides to this as well. Okay? For the most part, for our purposes, for analytical programming purposes, these are all benefits. Okay? Now, why Python? If you look at the distribution over time, the interest, Python is now the #1 programming language that is preferred and searched upon. And this is basically some kind of a popularity metric for programming languages. And you can see that Python has passed Java as the #1 course. And you can see that many of the languages are in decline. Python and few others are actually on the rise. If you compare to R, and I do have some experience with R, I have some students, PhD students, who work with companies that use R libraries. I've been hearing that most of those companies are now switching to Python as well. So Python seems to be the language to go when you deal with large data sets, analytical issues. So this is really a good time to learn Python and use it. Okay. So, but why did Python grow? First of all, Python is a relatively old language. It's not brand new. So it was actually, I think it was first released in 1982. That's a lot of time ago. Okay. Now, how did it all of a sudden become popular? Well, of course, it has these benefits. You can click on this link and read all these benefits that Python has. It's very elegant syntax. It's relatively simple. It has a large standard library that comes with the installation of Python. Interactive, so that means you can actually use the console just like a calculator and write a code, and you can actually see what the output is. This is unlike Java or C# where you have to compile the code and then use the interpreter to run it. In the Python case, you directly send the code to Python interpreter, and it actually runs it right there. So there's only one step in running the code versus running the code in 2 steps in Java or C# where you compile and then send it to the interpreter to run. Okay. You can embed, Python can be embedded into devices. So you can code everywhere. So because of this interpreter being it's an interpreted code, that means you don't have to compile. That means once you have the code, the same code will run in any device, Mac or Linux or whatever device you may have. Okay, it is free, finally. So, but these are all technical reasons. there's also a real reason. Is basically, this is what I call a catalyzing factor. Is actually, if you look at the founder of Python, a guy named Guido van Rossum. His name is right here. He is the creator of Python. Right here. And he was actually hired, I think in around 2005, he was hired by Google. Now that kind of helped both Google and also the language itself. So what happened is, when Google started using Python, switching from C to Python, what they did was they made the language more efficient. They optimized a lot of the features that are available in many of the libraries. So this kind of gave a nice support to the language itself. And at the same time, of course, looking at Google, other companies started using Python as well. So its story is not only the technicality, because technical side of Python has already been there since 1982, but at the same time, this catalyzing factor also helped Python become a language of choice, especially in the data analytics field and data science field. All right, so late 80s, it was created and used in many companies, from Google to Yahoo to Facebook to CERN to and so on and so on. Okay? The beauty is it's accessible to beginner programmers, as I said, and quickly write code and not really have to deal with a lot of the issues that you deal with as a beginner programmer in Java. All right, so let me skip this. So, what do you mean by Python being a higher level language? So what we say is the following. So if you have the source code, and this source code can run exactly the same way in multiple target platforms. So let's give it a try. So, all right, let me go ahead and start terminal. Now when I start my terminal on my Mac machine, so what I'm going to do is type Python. You'll see now the version 3.73 is the version that's been installed in this machine. I can go ahead and start typing the code that I have on the screen. I can just say subtotal is equal to 25. You notice now the variable subtotal is created, and I can actually look at it. I can just say subtotal. You'll see that it now holds the value 25. And then I can say tax is equal to 3, and then I can say total is equal to subtotal plus tax. Now you notice now the total variable will have the value of summation of tax and subtotal. Okay. Now I can again use my print statement and go ahead and print. Go ahead and print the value of total. Okay. So earlier it didn't work. I didn't close the parentheses, but now the total variable holds value 28. Now if we can look at the type of total at this point, the type is one of the functions that gives you the variable type. So we just say total. You look at now, total is going to be integer. Why? Because subtotal and tax were both integers, so this is going to be integer as well. Let's try something. Let's make tax is equal to 3.5. Now the variable type for tax will be a float, because it's a floating point number. Now even though I have the same variable, now I change its type. It was earlier it was an integer, now it became what we call a float. So this is what we call by dynamic types. So that means the variables in the function in the program can change its type. Now if I go ahead and do subtotal again, I'm going to go do the subtotal. Now you notice now the total is going to be 28.5. At the same time, the type for total will also change, and it will become float now. So this is what we call dynamic types. So the types will change accordingly. Okay. So let me get rid of this, terminate it, and let's continue. So that means I can just run Python code just like this, and it doesn't have to be interpreted. I can do the same thing in my IDE. Let me look at my Wing IDE. I think I have a version I've installed on my Mac machine. Again, as I said, I'm going to use both of these machines, Mac and Windows, interchangeably, because my code works exactly the same way in both of these versions. Okay, and this is the beauty. All right, so let's get this working. All right, so let me close. I have a bunch of programs open, but let me close all. All right, here we go. Now you can do the same thing in Wing IDE. If you open the IDE, you notice it's going to load the exact same Python 3.73. Now I can go ahead and use this. I can treat this part, this is called the shell, Python shell, and type just what I did. I can just say subtotal is equal to whatever, 20, was it 20? And it's going to work just like it did earlier. Okay. Or alternatively, I can go ahead and create a new file, and let's save this. Let me type something here. I guess I'm going to just do the same thing. I can actually copy and paste. Let's see if I can go ahead and copy and paste that from, instead of typing all that. I'm going to go ahead and here we go. I may have to clean it up a little bit, but this is, so I can go ahead and do this. And so now this code itself, I put it here. Let me save this as first example. I'm going to put it under on my desktop because I want to remove all these after I finish. Let's see. Okay, here we go. Now I'm going to go ahead and run this right here. You'll see now it's going to evaluate the first example Python file, and it will give me 28. I can go ahead now, do the other things I did earlier. I can just say print, and I'm going to say type of, let's say, subtotal or total. Let's do the total. Okay, and go ahead and run this. Now it's going to display 28, and it will also display and tell me that this type for total is integer. So it's a class, and integer is a class. Okay. All right, so let's get back. So I'm going to move this away for now. I ran out of space here. Here we go. All right, so what else? So that means Python is dynamic, so that means the values will change automatically depending on the variable types will change automatically depending on the values that are associated with them. And so what is the difference between compiled and interpreted language? Here it's written, it says compiler produces an executable program that may run many times with no additional translation needed. Here the interpreter will translate the source code into machine language, so that you have a machine, now you have a code. That code is not machine understandable. So what you need is an interpreter who it will take that code and turn it into machine code. So it will turn it into what we call a bytecode, and the bytecode will be turned into what machines can read. Okay? So languages like C#, C++, Java, and C are all compiled languages, and Python, Ruby, Perl, and JavaScript are what we call scripting or interpreted languages. All right, so we talked about differences between 2 and 3, and this is very critical. Please pay attention. You may have a Python 2 already installed in your machine, especially if you're using a Mac machine. Python 2 usually is installed there. So be careful, use Python 3 when you're trying to write the code, and also when you submit an assignment to me, let's make sure that we have the same version, 3 and 3 variants. Now, a couple of slides on this slideshow will basically show you what I just did with the Mac shell. And on the Windows, you can do the same thing. You can just go and you'll notice that when you run Python, it's going to find whatever Python that you installed, and it's going to go around that as well. And it's exactly the same way how it works. Okay. Now you can also run a program that you saved, right, by using the command line. Here you can, all you have to do is just say Python and name of the file. Here I'm just saying running the simple py file using the command window. This is very similar to Java. There you will say Java C, let's say simple.java to compile. Once you compile, you could just say Java and then give the name of the class without the dot class, and then you'll run it that way. It's similar to that, and it works exactly the same way. And some of the programs we're going to run, I think there is 1 or 2 programs that we need to run in the command line, but outside of that we can just stay with our IDE or the command shell, okay? Or not command shell, but the shell in the IDE, okay? All right, a couple of examples. If you want, actually, you can write the whole code in command line as well, in the command screen as well. Here I'm actually writing a simple Python program, and this is all being done. Again, I don't want to run this again, type all this, but what you can do is actually you can write entire code. Here what I'm doing is I'm creating a class called person, and class has its constructor. In Python later on we'll see them. They're called .__init functions. They're constructors, and then it gets 2 variables, name and the self. So now this code, you can actually write the whole thing here, create the class, and then go ahead and create one instance of that class. In this case, I'm creating a new person, and name in this case, this attribute is Kutsal Doğan, okay? And then I assign it to a variable called A. When I go ahead and look at the name of the variable or the object A, you'll see that it's going to be Kutsal Doğan. And this object that, or this class that I created can also give me one method, and that method is basically, it can say hello. So say hello method is basically takes the self, and then it says print hello, my name is, and then give it this name. So the name, remember, it is a class variable, so it's accessible here. So when you run the same code and say a.say hello, you'll see that it will know how to say hello. In this case, it will basically say hello, my name is Kutsal Doğan. Okay? So you can actually, again, we're going to see these classes and how we define them in chapter 13 later, but in a nutshell, you can actually do, if you want, which is not a good thing, but you can actually do the whole thing in the right here in the console. Okay? You could not do this with Java, because Java, you have to have it in a Java file which needs to be compiled. Then you can run it with the you can run it that way. Of course, there are online Java IDEs where you can do this, but in a typical IDE, what you do is you write the code and then compile it and run it. Okay? So in that sense, Python is a bit simpler to work with. All right, so, and the IDE itself is relatively simple. There is really not much I'm going to talk about the IDE throughout the semester. If there are a few things that I do differently, I'll just talk to them at that point. Now, if this was a Java course where we were using IntelliJ, or if it was a C# course where we were using, where we use Visual Studio, I could actually give you a lot of pointers. But in Python, we won't have many of those. This IDE is relatively simple at the same time. All right, so in the IDE, Ving IDE, you can go ahead, once you install, you can change or set the version of Python. You can do this using this portion right here. If you go to edit and configure, you can change the Python. If your IDE doesn't work, sometimes it doesn't work when after installation, this is the reason. So you gotta go here and find where your Python executable is for 3.7 and make sure that it's being used for running. If you just write Python here, I think it automatically finds this file, but if not, you have to browse and search and find it. Okay? So this is just to keep that in mind. All right. So we already did this, creating a new program and writing a code. So in the IDE itself, you can just write the code itself, and this will become, this one line that you have here will become a program. It's a program, you can run it right there. Okay. All right, but before you run, when you create a new program in Ving IDE, you have to save it. That's why I saved mine with, I think I said first example. Here, the example is saved as a first. And then you go ahead and click on the yellow arrow button, and then it's going to run your program. Okay. You can do the same thing. You can run the code, and there's a debugger also. You can debug, but for the most part, we are not going to use the debugger in this course. Our programs will be relatively short. We won't need really the debugger for the most part. In the interactive shell, we talked about this. You can just write a program right there as well. So just like writing it. Now what I'm going to do now is I'm going to run some of these programs. Simple is one of them. And then let's look at Arrow. So all the code that you see here are also available online. So let me show you where they are. So let's go to Python. For each lecture, I'm going to have you, let's go to week 1. I have these lecture 1 code, and this actually includes all the Python code you need for lecture 1. So let's click on this. Sometimes it has more than I actually cover in the class, but these are all the code that comes with the textbook. Now the textbook doesn't have this code printed. What I did was over the summer last year, I basically took the textbook and wrote all the code and made these files by myself just to run them also. And then created them so that you can also use them as well. Okay. Since our textbook is free, the author did not really go ahead and create these files for us. I had to do it, but nonetheless, it's already done, so you can use this. Okay. So let's go ahead and now look at lecture 1 code. I'm going to go ahead and find this. Now, I haven't used this in my Mac for a while. Let's take a look at it now. So what I'll do is let's get those files open. So I'm going to open them up. I think I do have a Python folder somewhere here, and under that folder I may have it, maybe not, so let's find it. Worst comes worst, I can go to Spring 2020 and I can look at my notes, week 1. I know the code is right there, right here. Okay, so I'm going to go ahead and open Arrow. There's circle. Let me open that as well. There's person, and there has to be try person. You notice that these files are duplicated because this was due to my cloud server. It was duplicating these files, and recently I switched cloud server. Hopefully these will all go away. Okay, let's open these files. Now you notice when I open these, all of these in my IDE, I'm getting multiple tabs for each of these files. Okay, so let's start with Arrow. Now Arrow is basically a bunch of print statement that gives you an arrow. I thought it was so right there. It prints out each of these. There's really not much you can do. I mean, here if you want, you can just use those tabs. Like you can just say tab, tab, and just like in tab. I'm assuming these are 1 tabs, so let's see if they are. If they're not, we'll know. Okay, so let's go ahead and run this again. Okay, so right there, that's less than a tab. So you notice it just moved it all the way to the right. So tab is about, let's see how many tabs. It's about 16 digits, I think. So tab here is gotta be 16 digits. Okay, 16 characters. Okay, sorry, I couldn't find a word for a moment. All right. So the next program is Circle. It's a bit more complicated program. So let's look at the Circle. So it's basically, this is a class called Circle. Now, what it does is it basically creates this class Circle, which later on can be used to draw circles. Okay, so the circle itself here has a radius. It does have a center and radius. Those are 2 things that circle has. So this class can be used to create circle objects, and then they can be used in other applications. So look, we already did this. Let's look at the person class. This is the person class we have used already. So what you can do in, just like in any programming language, when you create a class, you can either use the class right away in this program. Right here, you notice I comment these out. Or alternatively, you can use it in another file. From here, you notice I'm importing a class person from a file named person. And once I have this imported, I can now create an instance of a class and instantiate an instance using a constructor, and then go ahead and look at certain things about this. Finally, I can delete this. This is called a destructor. So let's run this. You'll see it's gonna go ahead and create an instance, Kutsal Doğan, and then go ahead and make it say hello. And then you notice when you delete this class, it now says Kutsal Doğan says goodbye. So let's take a look at the class definition, see why it's going on like this. In these classes, remember on the slideshow when we had this class, so let's look at it. Let me show you the class definition. Right here. Okay. So when I had this definition, you notice I only had one constructor and init, and then I had one member method. But if you look at this definition later on, the class is more involved, not a whole lot more, but a little bit more involved. In this case, the class has an constructor to create objects, and it has a member method to say hello, and then finally it has what we call a destructor. This basically is when an object is deleted or removed, and this is what destructor does. Destructor basically makes it say goodbye. Of course, in reality, when you have these classes, the constructors are used to create objects, but destructors are used to do what we call housekeeping when an object is removed. Now, an object like this, there is not much housekeeping. I'm just making it say goodbye. But think about an object which is a connection object, let's say connection to the database. In that case, there are all kinds of things that you may have to do before an object is destroyed. You may have to close the connection. You may have to send a message. There could be all kinds of things that can be done in this code right here. Now, if you look at the code itself, there are no curly braces. You are very used to them in your Java course. Here, there are no curly braces, but we have what we call indentation. So Python the code itself is written, the blocks are formed using indentation. So the space here, that white space right here is very important, and that indentation decides what is in the same block. So this class is one block, and these, whatever 3 lines, are one block. They are all in the same block. Okay. So this is the difference, and later on we'll discuss this a bit more in detail. Okay. So this kind of wraps up my introduction to Python, and I'm going to see you next time on some basics about Python.